Hello, everyone, wherever you are. Quick disclaimer as usual. We're talking about interesting things today, and interesting things are not allowed on YouTube. So I will be nuking the stream as I usually do before we get to the very, 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 I don't even know what you would want to call it because to me it's not controversial, but I don't know. For YouTube, sort of the stuff that they are considering misinformation as part of their community guidelines. And I have two scientists joining me today who we're going to talk about. We were just discussing before we went live about their thoughts on how you can possibly discuss science or participate in the scientific exploration process when you have tech companies that do not allow for asking questions. And so we're going to talk about all that stuff. But I just want to make sure everybody knows there are links in the description for Rockfin, specifically is where the live stream is going to continue on. But you can watch it later on my other platforms in its entirety, but you will not get the entire stream on YouTube simply because, I don't know, they just... they say that you're anti-science when you ask questions, but I think they're kind of anti-science. That's my read. So I hope everyone's doing well. I just want to make sure that we're live on Rockfin, which we are. And I'm going to bring in our guests. It appears, I think that, Julia, you got your situation worked out there. Oh, she's muted. Hang on. How do I unmute you? Can you hear me? Julia. Patrick, can you hear me?
I can hear you, yes.
Okay. Why don't you start with us? Because Julia, you're muted, so you got to unmute yourself. I don't know what's going on there. But Patrick, could you give us a little bit of your background, who you are and what you've done that brought you here today?
Well, I am a scientist who set up a small company about 30 years ago, and we make some equipment for actually crystallizing protein, but it's something that's used by structural biologists. So people, when you see these pictures of parts of the COVID molecule or proteins from the COVID virus, these are done by crystallography, and that's what we work on. I got interested in respiratory viruses about 10 years ago. I had a bet with a friend when I was in India, and I said, I bet I can show you proof that viruses respond to cold, the changes in temperature. And she said, oh, Patrick, don't be silly. That we all know that doesn't work. And so I said, I did some research and I sent her some papers, and she had completely forgotten about it. But anyway, that was how my interest in respiratory viruses began. And I published a paper in 2016 about really, the seasonality of respiratory viruses.
Julia, you want to give us your background real fast?
Absolutely. Thank you for having us today. This is really exciting because we worked on this great paper and we want to share it with everybody. So back at the beginning of the pandemic, so I'm a scientist. I do work for a large multinational biotechnology company, which may or may not remain nameless. We'll see if I forget to mention their name or not. But of course, I am not representing them here today. I'm representing myself. Early in the pandemic, I work with viruses. I use them as tools because what I do is I'm a process development scientist. So I work on purifying proteinaceous therapeutics. So mostly injectable drugs, and those are grown in cells, and the cells can be infected with the virus just like we can. And so we have to make sure that our products are free from viruses. So in order to put any sort of proteinaceous therapeutic in people, whether it's for a clinical trial or it's for a marketed product, you have to do what's called a viral clearance study, and you have to verify that your downstream process could kill or inactivate any viruses that made it into the cells that you didn't know about, even though we test for them. So I use viruses in my work, and at the beginning of the pandemic, when they said they were going to do mass PCR testing on everyone, well, I use PCR in my lab, and so do lots of people. It's a very, very common tool. But I thought, well, when I do my work, I can choose to do a cell-based assay in which I'm looking at whether the samples that I'm using in my experiment have live virus in them, and I can tell because they would infect cells if it happens. Or I can use PCR, which can just look for whether a gene is present. So whether the virus is just present, but it doesn't tell me what sort of state it's in, whether it's infectious or not. It could be just dead genomic material. And I thought, that's a really terrible idea. Like, in my opinion, like, why would you want to do that? Because you're going to get a lot of people who just have non-infectious virus in them. Anyway, so fortunately, very early on in the pandemic, I found Patrick's paper from the one that he wrote in 2016. I went, this is fascinating. This actually is a really interesting explanation of why seasonality happens. Why do we get cold and flu season when we get cold and flu season? You can almost set your watch by it, right? You know, it happens in the winter in North America and Europe. And so I thought, this is fascinating. I started following Patrick on Twitter. And when he said, hey, I'd like to update this paper, who wants to help me? I said, sure, I'll help you do that. And so we started collaborating on that and wrote the paper and published it in May.
So let's talk about that paper. What did you guys find? Tell us how this study worked and what are the main takeaways for people.
Should I go ahead?
Patrick,
so
you want to go first?
It's what's called a review. That's to say we read a lot of the literature and we've tried to make sense of it and put it all together. So there's no original work that Julia and I have done. And I wanted to make it, because when I wrote the 2016 paper, I basically wrote down everything I could think of about this subject. And I think the result was nobody read it. It was just too long and there was too much in it. So I wanted to make it a lot clearer. And when I asked people on Twitter if they wanted to look at it, Julia said she did. And she had all these suggestions to reorganize it. So I said, well, why don't you help me? So the paper is basically putting forward the hypothesis that the reason that we get more colds and flu in winter is really a side effect. It's something that happens as a result of a mechanism that's there all the time. And this is that viruses would like to keep out of your lungs. They want to stay in the nose and throat because that's how they can make you cough and sneeze, and then they can be transmitted. If they get into the lungs, they're not really going to be able to get to anyone else. They're just going to kill you. And before they kill you, they'll stop you moving around. They'll make you go to bed. They'll give you a fever. So there's this very strong selection that viruses should not go down into the lungs. And our hypothesis is that almost all respiratory viruses have found the same way of doing this, and that is they sense temperature, because the nose and throat are some of the coldest parts of the body. And if the virus can replicate there, then it can, without killing you, it can replicate quite vigorously and be transmitted. But so our hypothesis is that really all viruses are temperature sensitive. They grow at low temperatures, but they don't grow at high temperatures. And the seasonality is a side effect of that. It's kind of an accidental effect. Have I explained any more comments, Julia, that I've missed out there? Have you frozen?
No, is she frozen there? Uh-oh. Yeah. Well, I understand it. Hopefully she's going to come back. I'm guessing it's kind of a Wi-Fi thing. Maybe I should text her. So tell me this then. You did this research prior. Here she is. You did this research prior to. Oh, look, two Julias. Now, if that isn't miraculous science, I don't know what is. You do this research in 2016, so this is before COVID and everything. Why does your research become relevant at this point, talking about this particular virus and understanding it better, I guess? Like, what, in other words, how can we apply what you did back then to what we're dealing with right now?
Well, there are 2 points. One is that we would like to know if this virus is seasonal. So is it going to hit us more in the winter? And it's become really very clear that it is at least partly seasonal. So if you look at when epidemics hit in the Southern Hemisphere, they've appeared in the levels are much higher in their winter, and in the Northern Hemisphere, they're much higher in our winter. So it's clear that the virus is quite seasonal. But it's a new virus and it hasn't settled down, so it hasn't reached equilibrium. And it seems not to be as temperature sensitive as, for example, colds and flu and rhinovirus and all these well-known viruses. And that means it's a bit more likely to go down into the lungs. So the other part of the hypothesis is that it sheds light on the pathogenicity of viruses, because viruses that are respiratory viruses that are more temperature sensitive are probably less pathogenic, and the ones that are less temperature sensitive are more like Ebola. They just replicate wherever they can. So it's got a lot of implications for all of understanding this virus and all the others.
Julia, when you froze, Patrick's asking if you had anything else to add. I don't know how much you heard of what he explained, but you could even just give us your take on the value of it. Like what are the main takeaways for people and the value of it in today's context? Uh-oh, is she frozen again?
Yes, I did hear quite a bit
here
of
she is. Okay.
that. I hope you guys can hear me all right. No.
We hear you fine. You could just freeze a little bit, but just keep talking.
Sorry, I'm having trouble with my Wi-Fi.
It's okay. I'm a professional television personality, as you may know, so we'll figure it out. We'll stretch, as they say in the business. Go ahead. While we have you, though, tell us what your main takeaways are. Oh, she's freezing again. All right. Well, while we're waiting for her to unfreeze, I don't know. I got a question, if you don't mind, Patrick, about and I should add, this came from my locals page, AllisonMorrow.locals.com. Head over there if you like giving me story ideas. It's a great place to post them and talk with my community. But this was one question from Seth Underwood. What does cold weather and our noses have to do with increased viral infections in winter? Do these viruses like wet noses or dry noses? Is our forced heating systems drying our noses out, making it worse? Could the AC use in the summer be causing same problems as well? Any thoughts on that?
Well, yes, this is quite complicated. Most scientists will say that it's a matter that COVID is more transmissible because it's more stable in cold, dry weather. Julia and I think that the dry is not so important. It has an effect because we're not saying that, the survival of the virus outside the body has no effect at all, but we're saying that the key thing is the temperature, because when you are chilled, your nose and throat are chilled, and the blood supply to your nose and throat is also cut off a bit. So it's more likely that these less temperature sensitive viruses will replicate. So I can't remember the other parts of the question, but I think air conditioning, if you actually get chilled, that is not going to be good. It's best to be physically warm, and then you have a good blood supply to your nose and throat. But the other aspect, we think, is that the actual virus is biochemically sensitive to temperature.
I got another question. Not sure if this is your realm of expertise, but does UV light, A, B, or C kill the virus? Any thoughts?
Well, I do have some thoughts. I'm sure the answer is yes, it does, because UV light will damage any biological entity, including us, which is why we have we have melanin in our skin. But we don't think this is the main cause of seasonality. We think that the main cause of seasonality is actually the temperature in the air, and the UV effect is kind of secondary. There's a whole discussion about whether it's important to get UV because it gives you vitamin D. And again, I'm sure this has an effect, but I don't think it's the main driver of seasonality. And one reason you can see this is that every autumn, you tend to get an epidemic of colds and flu, but that is the time when people have the most vitamin D because it's at the end of the summer. So we don't think that's the main driver of seasonality and the most important thing.
Julia's back.
I'm on a different device. Maybe this will work better.
Someone from YouTube kidnap you or something for coming on and talking about this.
It sounds like Patrick was saying what I was going to say anyway, that he was going through the common ideas that people have for seasonality that we think are quite unsatisfactory.
Well, I had gotten a question about both like dry noses versus wet noses and air conditioning and heat and stuff like that. But then I'd also gotten a question about UV rays. killing the virus. So I think that was the last question that we were on. But since you're back, I don't know if you have any to go back to just the main takeaways of the research. Anything that you want to add to that?
I think what Patrick was saying before I unceremoniously disappeared, that the idea that people think that they already know what's happening with seasonality and these are the explanations and we're not going to look into it anymore because we've already solved that question is very frustrating, because I think there's a lot of indication that those aren't the only reasons. And I think when I read Patrick's original paper, I went, aha, this is really interesting. Why isn't anyone? It's not that no one is studying this. There are people who are studying this. Obviously we have a lot of references in our paper because it was a review paper and we're looking at a lot of other people's work. But it's also true that we've been looking at other papers that have been published since, looking at like, well, do viruses dock better on cells when it's cold, when you're cold, or things like that? It's like, okay, this could be part of it, but I think it's a completely rational idea to think that viruses can sense temperature somehow, and they're more active when they are cold, and not as active when they aren't. And it goes down to an individual level.
So when you're talking about, here's another question that just came in. Any idea what food or drug might bind to the virus? I don't know if I understand that. Do you understand that question?
No. Like I said, we're talking about temperature, but I mean,
right. I don't know where that.
I'd say that's a nice idea. If there was some food that could make you better, that would be wonderful. But I don't know of any such food.
What about saunas? Somebody asked about that.
I have an opinion about this.
Yes, I was going to say our conclusion kind of talks about that.
Yeah, it does, and this hasn't really been studied. I think people are beginning to look at this. So if you make the body really hot, does this get rid of the virus? And I actually don't think it does. I think it's very important not to be chilled, but being very hot doesn't seem to be very beneficial. I mean, it might have a small effect, but it doesn't seem to be very beneficial.
Why then do we have fever? Because isn't fever your natural, your body's natural reaction to killing off a virus?
That's a difficult question. And if you look in Wikipedia, there is no very well-established answer.
Wikipedia, don't get me started on them.
Well, okay. But I think you're right. And I think the main reason why you get a fever is probably to stop another virus infecting you. So it's just to sort of tip the balance to be slightly higher temperature, and it's obviously good to be warmer when you have a virus. But actually, taking aspirin, and you call it Tylenol, I think we call it paracetamol, this does not seem to make colds and flu worse. So if the fever was really important, you'd expect it to have more of an effect.
That's interesting. I did get this question. Alice Mara, will high altitude wine help kill the virus? I'm going to say no, but you should buy my high altitude wine. This is my wine sponsor. Many people know, AllisonWinePromo.com, AllisonWinePromo.com, Allison with 1L, third highest vineyard in the world. And you support a pro free speech channel, saying thank you to Bonner Wine for being my wine sponsor. And I will say, y'all, I don't know if you two knew this, Julia, you may have, that I got suspended from YouTube for showing videos from CNN and NBC breaking YouTube's rules. And then they suspended me for playing the videos, but the videos were still up on the corporate news sites. So anyway, thank you to everyone who bought my wine while I was in jail. I really appreciate it. It does help keep me going. So anyway, again, AllisonWinePromo.com. Thank you for reminding me about that.